let's take a look at this example. In order to find I total, I'm going to find total resistance first. Okay, so if you want to solve problem like this, you're supposed to start solving this circuit from this side. Okay, don't start from the voltage source, start from the back. Okay, so please notice that these three resistors connected in series. So this is R5, 6, 7. Okay, this is going to be my equivalent resistance for these three resistors. So this is R5 plus R6 plus R7. So R5, I can say also R5 to 7 is equal 2K plus 1K plus 4K. Remember, write formula first, always. So R57 is equal 2K plus 1K plus 4K. This is equal 7K. Okay, this is 7K. So now we can redraw the circuit. And the circuit is going to look like this. I have R1, this is R2. Okay, next one we have R3, this is R4, and this is my resistor R57. Okay, and this is my ground, of course. So now we can see that resistor R4 is in parallel with R57. So I can find the resistor R4 to 7 because they are in parallel and I have just two of them. So I'm going to use product over the sum of R4 times R57 over R4 plus R57. So let me write this down over here. R47 is equal, R4 is 3K times 7K over 3K plus 7K. Okay, this is equal 3 exponent 3 times 7 exponent 3 divided by open parenthesis 10K. Okay, because 3K plus 7K is 10K. So this is 2.1 kilo ohms. Okay, so now I can redraw the circuit again. Okay, so this is my voltage source, and this is my R1, this is my R2, and this is my R3, and this is my resistor R47. Okay, of course this is my ground. So now we can see very clear that these two resistors are in series. So I can simply write that my R3 to 7 is equal R3 plus R47. R3 is equal to K plus 2.1K is equal 4.1 kilo ohms. Okay, so this is the equivalent resistance for these two resistors. Next, I supposed to redraw the circuit one more time. So I recommend redrawing for all of you who don't understand the concept yet. So I have R1 and this is R2. Okay, this is my ground, and I have my resistor over here. This is my R37. So now I'm supposed to find R27. Okay, I have to combine these two resistors together. They are in parallel and there are just two of them. So I'm going to simply write this is R2 times R37 over R2 plus R3 7. So R2 is equal 4K. So I have 4K times R27, no, times R37, which is equal 4.1 K over 4K plus 4.1 K. And this is equal 4 exponent 3 times 4.1 exponent 3 equals, divide by open parenthesis 4 exponent 3 plus 4.1 exponent 3 close parenthesis. This is equal 2.02K. This is 2.02K. Okay, so this is my resistance R27. Next, I can redraw the circuit one more time. Okay, so this is my circuit, and this time I have R1 and resistor over here R227. So now these two resistors are in series. Now I can find the total resistance. R total is equal R1 plus R27, where R1 is equal 3 kilo ohms plus 2.02 kilo ohms. So I have R total is equal 5.02 kilo ohms. Okay, so this is my total resistance. Someone is going to say this is simply 5 kilo ohms and 20 ohms, and we can say this is approximately 5 kilo ohms. But you know, I like to keep 2 decimal places. That's why I'm going to keep this two. If you are going to use just 5K for rest of the calculation, is also okay. But I want to be more accurate. That's why I keep two digits after the decimal point. So I found R total. Next, I can find I total. Let me write this down over here because I want to save the space. I total is equal voltage source over R total, where voltage source is equal 20 volts over 5.02 K, and this is equal 20 divided by 5.02 exponent 3. This is equal 3.98, of course, milliamps. Okay, so this is my I total. You're supposed to realize that I total is the same current. I total is the same current which will flow through the resistor R1. So I can say that I total is also equal to I1. Okay, but the problem is not asking me to find I1. We're supposed to find I6 and we're supposed to find V3. So what I'm going to do right now, I'm going to simply, I can use this current to find voltage across this resistor. Okay, so V27 is also equal to the voltage across resistor V2. If I'm going to find voltage across this resistor represents these two together. So voltage across this resistor is also voltage across resistor R2 because these two resistors are in parallel. So this is equal I total times R27. I total is equal 3.98 milliamps times R27, which is equal 2.02K. So we can say V2, okay, V2 is equal to V27, and this is also equal to V37, okay, because voltage across this resistor is equal to the voltage across this resistor and voltage across this resistor. So this is equal 3.98 4.98 exponent 3 negative times 2.02 exponent 3. This is equal 8.04 volts. This is my V2. Okay, next I supposed to find V3, because the problem is asking me for V3, right? So I found the voltage V2. This is my voltage V2 over here. Okay, and I can look at this circuit right now, and please notice that V2 is the voltage across these two resistors, and these two resistors are in series, and I'm looking for voltage across this resistor. So what I'm going to do, I'm going to use voltage divider formula to find voltage across resistor R3. So V3 is equal V2 times R3 over R3 7. Okay, this voltage times this resistance over the total resistance of these two resistors. So this is the voltage divider formula. So V2 is equal 8.04 volts times R3, which is equal 2K, over R3 to 7. 3 to 7 is equal 4.1 K. So this is equal 8.04 times 2 exponent 3 divided by 4.1 exponent 3. This is equal 3.92 volts. 3.92 volts. So we found V3. Okay, we found I total and we found V3. Next, we're supposed to find, we can find P4 because we are very close to P4. So we have to find voltage across resistor R4. Okay, so voltage across resistor R4 is equal to the voltage across resistor R47. Okay, because this resistor represents these resistors together, right? So because R4 is in parallel with this one, so it means voltage across this resistor is also equal to this resistor. So I can say that my V4 is equal to V427, and I'm going to find it by simply subtracting. I'm going to use KVL V2 minus V3 will give me this, right? So V2 minus V3, which is equal, this is going to give me V4. So V2 is 8.04 volts minus V3, 3.92 volts, and this is equal, let me use the calculator, so I have 8.04 minus 3.92, this is equal 4.12 volts. Okay, so this is the voltage across resistor 4. Because I have voltage across this resistor, I can find the power. So P4 is equal V4 to the second power over R4. V4 is equal 4.12 volts to the second power over R4, which is equal 3K. This is equal 4.12 to the second power divided by 3 exponent 3, and this is equal 5.65 milliwatts. 5.65 milliwatts. Okay, so this is my power P4. I found P4. Next, I supposed to find supposed to find the current I6, right? So please notice that the voltage across resistor R4 is the voltage across these two resistors, R5, R6, and R7, right? So this voltage divided by the total resistance of these three resistors is going to give me current which goes through these three resistors. So I can say that my I6 is equal to I5, and this is also equal to I7, and I'm going to find it by simply dividing V4 over R5, 6, 7. So V4 we found is equal 4.12 volts divided by R567, which is equal 7 kilo ohms. So I got 4.12 divided by 7 exponent 3. This is equal 588.57 microamps. 588.57 microamps. Okay, so this is my current I6. Okay, so next I supposed to simply find V7 because we found I6, so now supposed to find V7. V7 is equal I7 times R7, where I7 is equal 588.57 microamps times R7 times R7, which is equal 4 kilo ohms, and this is equal 588.57 exponent 6 negative times 4 exponent 3. This is equal 2.35 volts. This is 2.35 volts. Okay, and we have found V7. Next we're supposed to find the total power. P total is equal voltage source times I total. Voltage source is equal 20 volts times I total, which is equal 3.98 milliamps. Okay, this is my I total over here. So I have 20 volts times 3.98 exponent 3 negative. This is equal 79.6. This is equal 79.6 milliwatts. Okay, if you solve this problem a little bit different way, your answers could be a little bit off, but if they are close to mine, means you solved the problem correctly. Okay, so we can say that the problem is solved.